Okay, well, thank you. And I don't know of any other subject where it's easier to get a spiritual conversation going than talking about global warming or climate change. I mean, now that COVID is over, that's kind of the number one water cooler subject that people want to talk about. And I've heard that here in Hawaii, it's even a bigger issue than it is in the other states of America. So what I want to do is equip you to take the subject of climate change to get a spiritual conversation going and really getting people to think about far more important issues of life. Okay, I've actually written an entire book on climate change. Oh gee, let's see. This is what happened last night. I got to pull out of this and start it up again, okay? Here we go. And weather can change a lot too. I took this photo on August 2nd. The day before was 85 degrees Fahrenheit. 24 hours later, 15 degrees Fahrenheit. So there's my wife struggling through the snow when she thought she was going to be having to just hike in shorts and a t-shirt. So parts of the world, the weather can change just as much as climate change. As you can imagine, this was in Canada. And Canada is a place that's warming 5 times faster than the rest of the world. So Canadians are very concerned about climate stability and climate change because they're taking it more than anywhere else. There's also parts of the world where they got the problem of cooling. So Eastern Europe is getting a lot colder than it used to be. And so when they talk about climate change and global warming, it's always a worldwide average. Parts of the world are warming up much faster. Parts of the world are actually getting colder. So, weathering climate change. Now, what I find gets a water cooler discussion going is saying, are you aware that climate stability is the exception and not the norm? The norm for planet Earth is extreme climate instability. What we've been experiencing the last 9,500 years is unprecedented in the history of the Earth. We've been enjoying extreme climate stability. So I want to begin this talk about the design features, really recognizing that this climate stability we're enjoying right now is a gift from God, and is a way to really get a discussion going about supernatural design. Now, if you want to have humans on planet Earth with civilization, we need to be in an ice age cycle. An ice age cycle is where the planet goes from being covered with 10% ice like it is today to where it's covered with 23% ice. And that cycle happens about every 100,000 years. So this is what it looks like right now. North America gets the biggest hit from the ice age cycle. But in a warm interglacial, 10% of the planet Earth is covered with ice, and about 10% of North America is covered with ice. Now, for the rest of the world, during an ice age, 23% is covered with ice, but for North America, it's 55% gets covered with ice. And Rick, I know you came from San Diego. During the last ice age in the wintertime, the port of San Diego would be clogged with ice. Matter of fact, the northern ports of Mexico were clogged with ice during the last ice age. And a good chunk of the ice came all the way down into Southern California. So it cycles between 55% and just 10%. And the periodicity is about 100,000 years. And you typically get about 8 to 10,000 years of an interglacial and about 90,000 years of an ice age. And so during an ice age, it's predominantly ice. Now, it's critical we be living in an ice age cycle. And only for a tiny percentage of Earth's history has there been an ice age cycle. But the benefit of being in an ice age cycle is that melting glaciers left over from the last ice age water the rich agricultural plains. And so this is what the ice age looked like. This blue stuff is where you have 1,000 feet minimum ice thickness or more. And as you look at this map, what you recognize is that the world's great rivers flow out of these ice regions. So for example, we have what's called the third pole. The third pole is the Tibetan Plateau. Average elevation is 17,000 feet. So even though it's close to the equator, because of how its high elevation, it literally has a store of ice that's greater than what you have in the polar ice cap. And that melting ice feeds 20 major rivers that make possible agriculture that sustains 4 billion people on the face of the planet. Take that ice away, and there'd be no water to feed those 4 billion people. And so the biggest rivers flowing out of Asia all flow out of the Tibetan Plateau. And this is the only time in the history of the Earth where there's been a third pole. It's the only time in the history of the Earth where you've had 1 million plus square miles above an elevation of 17,000 feet that's close to the equator. And if you look in Europe and North America, you go down to South America likewise, you can see that the great agricultural plains are being watered from the glaciers that are left over from the last ice age. The Mississippi River, the Missouri River, for example, are flowing from ice in the Rockies. Now, the other benefit of being in an ice age cycle is that the ice age cycle is characterized by these thousands of feet thickness of ice sheets, but when the ice age is just about to come over, that ice melts very rapidly. Within 1,000 years, you go from 23% of the planet covered with ice to just 10%. So you get this very rapid melting of the ice. And that rapid melting of the ice generates powerful winds that blow off the high plateaus and take dust off those high plateaus, and they dump it on the low agricultural plains. That dust is nutrient rich. So what happens is every 100,000 years, the great agricultural plains get fertilized. And they get fertilized by two mechanisms. It's that strong wind blowing off the plateaus that have recently been denuded of ice. But the other thing is with the melting of all that ice, 3,000 feet thickness of ice over the Canadian Shield and over the northern states of the United States, what that does is it presses down. It's a huge weight, and it pushes North America down into the mantle of the Earth. When that ice melts, you get a gravitational rebound. North America bounces back up. Siberia bounces back up. And that rebound effect ignites volcanoes all around the world. So if you were to go back 12 to 14,000 years ago, you got these volcanic eruptions all around the world. And hey, you live in the Hawaiian Islands, which are basically volcanic islands. And I think you're all well aware, volcanic soil is incredibly mineral rich. There's a reason why agriculture, I mean, what's the saying here? In Kauai, you can grow anything. And you don't really have to worry about it. You've got the water, you've got this very mineral-rich soil. You can grow anything without paying much attention to it. That was a worldwide phenomenon where you get all this volcanic ash and dust being dumped on the agricultural plains, which makes it possible for us to grow. You've got the fertilizer, you got the water, and you can grow this abundant food, not only to feed 7.5 billion people, but to feed the hundreds of billions of animals that are part of our agricultural support. Now, in my book, Weathering Climate Change, I actually list 12 more benefits we get from living in an ice age cycle. But these are the 3 that are most important for sustaining our food supply. We wouldn't be able to have a large population. And what you see in Revelation chapter 7, verse 9, is that the redeemed host that John sees in his vision is an uncountable number, which means God had intended all along that billions of human beings would come into a relationship with himself, which means we need a planet that can provide the food to feed billions of human beings in such a way that they can also sustain the civilization and technology as necessary to take the good news of salvation to all the people groups of the world. The other 12 benefits basically focus on what's necessary to ensure we get the technology and the civilization and the transportation we need. I mean, to give you one obvious example, if you go to Norway or you go to British Columbia or to Alaska, you see these deep fjords. Those fjords were cut out during the last ice age. which makes possible the transport of shipping around the world. I mean, you go down into Tasmania, for example, or the port of Hobart is a huge fjord cut out from retreating ice left over from the last ice age. And I think there's even an aesthetic effect that we get from living during an ice age cycle. The last ice age was the most severe ice age in the ice age cycle. And the greater the severity, the greater the geological transformation we get. And so I think a lot of you have heard of Yosemite Valley. Yosemite Valley didn't exist until 15,000 years ago. The retreat of the ice sheet that was covering a good chunk of California carved out this amazing canyon. And actually, if you go a little bit north of Yosemite Valley, you'll see almost an identical canyon that was cut out. Unfortunately, they put a big dam there and filled it up with water, the Hetch Hetchy Reservoir. But it's actually just as beautiful as Yosemite Valley. And there's valleys like this all around the world. And what I've noticed is when I personally have taken people into these locations, there's something that happens to them that is spiritual, that is aesthetic. The beauty of the place just transforms. Here's one of my favorite places. These are the tallest waterfalls in North America. These waterfalls fall over more than 2,000 feet over these granite walls. And what you see here is just 5 of 24 waterfalls that flow over the walls of this canyon. When you get in the middle of it, you're just surrounded by these massive waterfalls. You say, how do you make that happen? There's glaciers on top. And in the summertime, they melt, all this water pours over. And when you're in the valley, there's rich soil there, and you can just scoop up all the wild berries you want as you're taking photographs of this kind of place. Being in interglacial, where you're following the most severe ice age in the ice age cycle, produces this magnificent scenery. And literally, this is all around the world that we get to see this. Okay, but it's a real challenge to get an ice age cycle at this point in the history of the Earth. And so part of it is what's going on with the sun. And I think I've shared this with you before, that stars are like human beings. They're unstable when they're young, they're unstable when they're old, but they're maximally stable when they're middle-aged. And in the case of stars, they have to be perfectly middle-aged. So the sun right now is 4.57 billion years old, which means it's exactly halfway through its nuclear burning phase. Only when it's exactly halfway through is the solar flaring activity at a sufficiently low level that human beings can live. You say, oh, how wide of a window we're talking about? Well, if you want the flaring activity to be low enough and the luminosity stability to be sufficient, as I shared on Sunday morning, the window is only 100,000 years wide. And I was asked on Sunday morning, well, how many years do we have left? Less than 50,000 years. Now, that should affect your eschatology, your interpretation of end times prophecy in the Bible. It means that God's going to need to wrap things up within the next 50,000 years. And actually, what I'll be sharing with you tonight, he needs to wrap it all up before the next ice age comes upon us. And that'll be a lot sooner than 50,000 years from now. But the flaring minimum occurs when the sun is 4.57 billion years old. The luminosity stability lasts less than 100,000 years. But the sun gets brighter and brighter. Our sun is a gigantic hydrogen bomb. It's basically fusing hydrogen to helium. And when it does that, it releases enormous amounts of energy. But helium has a higher density than hydrogen. So as the sun continues to fuse hydrogen to helium in its nuclear furnace, the density in the core of the sun increases. That density causes the nuclear furnace to burn with ever-increasing efficiency, which means that the sun today is brighter than it's ever been in the history of life on planet Earth. And for 90% of the history of life on planet Earth, our planet has had no ice at all. So here's the challenge. How do we explain all this ice on planet Earth today when the sun has been brighter than it's ever been in the history of our planet Earth? How do we get the ice? We need the ice. Without the ice, we couldn't have our human population. And so a good chunk of my book, Weathering Climate Change, talks about the amazing design features and events that made possible an ice age cycle when the sun is brighter than it's ever been before. And you say, well, why couldn't have God created us human beings earlier? If he did, the flaring activity would be thousands of times more intense than it is now, and it would be impossible for us to live. The microbes can survive. They can do just fine. And maybe you can have plants here, but you can't have humans until you get here. We have to be here at the brightest time in the sun's history. Well, I'll give you just some of the highlights. Number one, there was a gigantic asteroid that hit off the south tip of South America, and it was discovered by accident. What happened, there was a research vessel that was going around the south tip of South America, and they happened to be scanning what was going on in the ocean floor, and they said, we see a gravitational anomaly, we better go check this out. And so they wound up, and it's 17,000 feet deep at this point. They went down to the bottom, and what they discovered was a huge debris field of asteroidal material, and it covered 500 square miles. And so they realized there had to be an asteroid at least a mile in diameter, maybe as much as 2.5 miles in diameter, that struck the ocean at this location with such force and went all the way down to the bottom of those 17,000 feet, hit the bottom, and then generated a chemical reaction such that sulfur aerosols spewed out into the atmosphere and basically brought what's called a nuclear winter upon the planet. Generated so many sulfur aerosols that it literally blocked out the light of the sun for a 4 or 5 year period, causing an enormous cooling event, and it was that cooling event that began the growth of the Antarctic ice cap. And ice reflects sunlight with 60% efficiency. Compare with open ocean water that reflects it with only 6% efficiency. So that increased reflection of sunlight began to cool the whole planet. It led to the generation of the Greenland ice cap because that was at high elevation. And so ice formed there. Ice began to form at the polar ice cap. It began to form over the Tibetan Plateau. So it was this collision that generated the production of ice all over the planet. And again, the cooling period from the asteroid only lasted about 5 years, but that was enough to ignite sufficient ice that more and more sunlight got reflected away. And what happened recently is they were able to remove all dispute about this giant asteroid collision, because what they discovered was evidence for a tsunami that had a worldwide impact. Basically, when this asteroid smashed into the ocean, it generated tidal waves 1,000 feet high. And they actually are able to find the splash pattern of this tidal wave in the Adriatic Sea. So it literally impacted all the oceans in the world, even the Mediterranean Sea, even the Adriatic in the Mediterranean Sea, all around the Pacific Rim. You can see evidence for this gigantic tidal wave that was a direct result of this. Now, they've been able to date this. The date is about 2.58 million years ago, and that's also the same date we have for the beginning of the Ice Age cycle. Previous to 2.58 million years ago, no Ice Age cycle. When this impact hit, it ignited the Ice Age cycle. The planet finally became cool enough where Earth was very delicately balanced between being completely covered with ice and having no ice at all. That's what it takes to get an Ice Age cycle. You need that delicate balance between permanent whole planet covered with ice and having no ice at all. And what this did is it generated an Ice Age cycle with a periodicity of 41,000 years. And that's to be expected because the tilt of Earth's rotation axis varies from 24.5 to 22.1 degrees. And when it goes down to 24.5, the planet gets warm. When it goes back up to 22.1, it gets cooler. That's really one of the predominant effects driving the Ice Age cycle, which causes it to go from 10% ice to about 23% ice. If you're wondering what's happening now, the tilt of the rotation axis is going back to 22 degrees. So that's causing the planet to get colder. But there was a second asteroid that hit, and actually astronomers now think it might be a comet. Because when comets crash into the Earth, they're 85% frozen water. And so when they go through Earth's atmosphere, they typically split apart. A stainless steel asteroid remains contiguous, but a comet will often break apart. And so you typically get multiple craters, which is what we see in this case. We have evidence that 785,000 years ago, a comet hit in the South China Sea, right smack on top of what is now known as the Spratly Islands. And what geologists now realize, there was a big island in the South China Sea. This comet hit it and basically obliterated the island, so all that's left are these tiny islets that we call the Spratly Islands. But just a year ago, they discovered another crater. And so if you look over into Laos, you can see a little ellipsoid, which is a second collision site. And actually, geologists are busy trying to see maybe we can find a third collision site or a fourth collision site. But what they recognize is that this comet striking the Spratly Islands and the Laos set up a huge dust cloud into interplanetary space. And our planet goes through that dust cloud once every 100,000 years. That's not the only factor that changed the Ice Age periodicity, but is one of the predominant factors. And so what happened was, about 800,000 years ago, the periodicity changed from 41,000 years to 100,000 years. Now this is important for human civilization, because with 41,000 years, your interglacial is only going to be 2,000 years long. That's really not enough time to get global high-tech civilization up and running. But if you have a 100,000 year periodicity, now we're looking at about 10,000 years. In fact, we're in an interglacial. That's the longest of all. We've been in it for 14,000 years. That's by far the longest of the interglacial. And actually, human activity is the main reason why we've been so long in an interglacial. We're actually 5,000 years overdue for an ice age. So I mentioned earlier that the tilt of Earth's rotation axis has been cooling the planet for the last several thousand years. It's human activity that has warmed the planet enough to compensate for the natural cooling that is going on. And this 100,000 year cycle, there's that dust cloud we pass through, but the 100,000 years is also equivalent to the change in the shape of Earth's orbit. Every 100,000 years, our orbit becomes more elliptical than less elliptical. When it becomes more elliptical, the planet gets warmer, less elliptical, it gets cooler. So what is it doing now? It's actually cooling the planet. So the change in Earth's orbit is cooling the planet. The change in Earth's rotation axis tilt is also cooling the planet. The launch of human civilization has been warming the planet. Okay. This is what the Ice Age cycle looks in terms of temperature. And so you can see that the temperature jumps up and down by about 12 degrees centigrade over the last 3 Ice Age cycles. This looks in detail at what's been happening from 100,000 years ago to just before the start of the interglacial, some 14,000 years ago. And what you notice here is that the temperature is jumping up and down very aggressively. We have the global mean temperature jumping up and down by 8 to 10 degrees centigrade on time scales of just a few centuries. Now, you read Genesis chapter 4, and it talks about humans being involved in agriculture, they're planting crops, talks about metallurgy, and yet if you read your history books, the Bronze Age didn't start until 3,000 years ago, the Iron Age not until about 2,500 years ago, Copper Age maybe 4,000 years ago. We're now finding evidence that humans living during the last ice age were actually involved in metallurgy, agriculture, and even in complex bakery manufacture. In fact, there's been papers published in the last couple of years making the point that humans living 36,000 years ago were planting crops, were harvesting the crops. They were roasting the grains, grinding the grains, and making bakery products. And so, but it's all on a very small scale. It has to be because of this extreme climate instability that they're dealing with. That extreme climate instability means you can't specialize and only grow rice or only grow wheat. You have to plant a multiplicity of plants, say 15 different crops, and expect that the climate instability is going to cause 9 of them to fail. Maybe 3 will be okay, and you feed your family on the 3. And likewise with metallurgy, given the climate instability, it's just too difficult to develop any kind of a sense of a factory or a manufacturer, and you simply can't grow enough food because during an ice age, the carbon dioxide level drops down to about 175 parts per million, which means you don't get as much productivity from the crops that you plant. And so once you're into an ice age, that climate instability basically means that you have to marshal about 95% of your population just to get barely enough food to keep everybody alive. So you really can't set people free to do art or music or theology or engineering or science. Everybody's got to be focused on trying to get enough food to feed everybody. But you do see now emerging evidence. So for example, as this ice was melting, we're actually finding that these peoples that were living 15,000 years ago, they'd be going over the ice and the snow and looking for meteorites. 1/4 of the meteorites that fall are a better grade of stainless steel than we put out from our steel factories. And so people would gather up these meteorites and cold forge them into very sophisticated tools. So these people weren't dumb, but they were hampered by extreme climate instability. Okay, what changed all that? What changed all that was a third asteroid collision that hit about 12,800 years ago in northwest Greenland and caused what has long been noticed in the scientific literature, the Younger Dryas cooling event. Probably a lot of you have heard of this. Only in the last couple of years have they discovered the cause of the Younger Dryas cooling event. All they knew was that, with an ice age, let me go back to this diagram here. Okay, the ice age cycle is characterized by the temperature rapidly rising to a peak, usually about 2 to 3 degrees centigrade where we are right now, and rapidly dropping back down into an ice age. We now appreciate what happens here. When it jumps up to this point, it melts the polar ice cap. When you melt the polar ice cap, instead of the polar region reflecting sunlight with 60% efficiency, it reflects it with only 6% efficiency, which means the Arctic Ocean now absorbs a lot more solar heat. What does that do? It produces water vapor. What happens to that water vapor? It falls as snow on Canada and Siberia. The only reason why Canada is not covered with thousands of feet of ice today, it's a virtual desert. It only gets about 10 inches of rain equivalent per year. And so yes, it snows, but it doesn't snow enough for the snow to accumulate to make ice. But double that or triple that, within a few centuries, you cover all of Canada with hundreds of feet thickness of ice. Give it 1,000 years, it's 3,000 feet thick. Same thing happens to Siberia. And so as we look at this Younger Dryas cooling event, it prevented the global mean temperature from rising to a point where it would melt the polar ice cap. It forced things to stop short of that, and then we have this long period of global mean temperature stability. What generated that stability is the Younger Dryas cooling event cooled the planet by about 10 degrees, then it recovered, began to warm, but fell short of going up to the typical maximum, briefly stabilized, and when it briefly stabilized, humans launched civilization. We call it the Neolithic Revolution. about 12,000 years ago, the climate stabilized and humans realized we can now specialize. It's the first time in the history of humanity where you see groups of people saying, we're only going to raise goats, or we're going to raise tens of thousands of them. And we're going to have so much goat milk, so much goat meat, so much goat leather, we can trade it with people that are specializing in only growing wheat. It's the first time where people were able to upscale and specialize, produce such a huge surplus. For the first time in human history, they said, we got so much food, not everybody has to be involved in agriculture. We can have artists, we can have musicians, we can have engineers. And that's when they began to build cities, and the ports, and roads, and the commerce, and nations began to form. And again, a serendipitous discovery. It was a NASA aircraft flying over northwest Greenland 3 years ago that by mistake had its deep ice, radar ice penetrating turned on. And so as they flew over this region, it says, oh, we see this anomaly. There's this, looks like a crater. And so what they discovered with their radar accidentally turned on is they found what looked like a crater underneath 3,000 feet thickness of Greenland ice. They sent a team of geophysicists there, and they went on the edge where you got that rock, and they looked at the meltwater coming out from underneath the glacier, and it had the isotope signature of a gigantic stainless steel asteroid that struck there 12,800 years ago. What did this collision do? Well, at that time, there was a gigantic lake in the middle of North America. The ice was receding from the previous ice age. Lake Agassiz had covered a good chunk of Manitoba and Saskatchewan, Ontario, Minnesota, North Dakota was covered by this lake. It was filled with glacial melt and was draining down into the Gulf of Mexico. When this giant asteroid hit in northwest Greenland, it threw gigantic rocks and chunks of ice up into the atmosphere, and a lot of it fell on the northern part of North America. And what happened is it blocked the flow of water going into the Gulf of Mexico. So this southward stream was prevented. This got blocked up, and it opened up two more escape routes for that glacial meltwater. One that ran through the Mackenzie River into the Arctic Ocean, the other through the Great Lakes, out the St. Lawrence, and out by Newfoundland. And there was a powerful current at this time driving water through the Canadian archipelago, down between Greenland and Baffin Island. And these two streams of cold water met together. And what did they do? It turned back the Gulf Stream, which cooled all of Europe, cooled all of North America, and wound up cooling the rest of the world as a result, and prevented the global mean temperature from going up to its normal high of 2 or 3 degrees centigrade. And again, as I said, it briefly stabilized the climate. Humans developed the Neolithic Revolution. They began to domesticate cows in large numbers. And cows, as you're probably aware, emit huge quantities of greenhouse gases. They began to cut down forests to make for pasture lands. That also caused greenhouse gases to go in the atmosphere, but at such a rate that it perfectly counterbalanced the natural cooling. And so we get the cooling from the change in Earth's orbital period, the change in the rotation axis. All that natural cooling was perfectly counterbalanced by human activity, and the human activity began to increase in perfect pace with the increase in the cooling. So for 9,500 years, the global mean temperature did not vary by more than 0.65 degrees centigrade. And it was that extreme climate stability that enabled human civilization to foster, the human population to go from just a few million up to hundreds of millions, and then up into billions. All that happened because of the perfect balance between the natural cooling and the warming from human activity. And what has just been published, this is not in my book because the book went to press a few months ago, but what is brand new, just got published, is a detailed study where they said, you know, the problem with our temperature measurements, they're all on the continents, and we need to take out the elevation effect. So for example, if you were to have a weather station up in Kokee, because it's 4,000 feet above sea level, you're going to get more variation than you will if you have a weather station that's close to sea level. So what scientists did is they said, we're going to take temperature measurements about 100 to 500 miles offshore of all the continents, where we're only looking at temperature measurements that are at sea level. But we're going to do it close to the continental shelves so we can actually get an idea of what's really happening at sea level on the continents all around the world. And this is what they came up with, that for the last 1,000 years, up until about 1920, the global mean temperature was stable to within 0.06 degrees centigrade, which explains why from year 1000 up until the present, we've seen this phenomenal advance in technology, civilization, and population. The climate actually stabilized from plus or minus 0.65 degrees down to plus or minus 0.06 degrees. The greater the climate stability, the more confidence you have that when you plant crops, you're going to be able to predict what kind of harvest you're going to get. And likewise, you can specialize and scale up. And so it's such today that in the United States, less than 1% of our population is dedicated to food production and food processing. What do the other 99% of us do? Some of us become pastors, some of us become astrophysicists, some become musicians, some become software engineers. If you can devote 99% of your population to music and art and literature, science, technology, engineering, medicine, mathematics, you'd be amazed what can happen. And so you look at this amazing technological advance we have. Let's give credit where credit is due. We live on this amazingly designed planet where God was able to intervene and make sure that we have this perfect balance between multiple temperature affecting things to give us a climate stability that never before has been seen in the history of planet Earth. Why did God do this? He wants to redeem billions of people unto himself. For that to be possible, we need this extreme climate stability. But look what happens here. The last 70 years, the global mean temperature has gone up 1 degree. By the way, if you look back to this curve right here, yes, not that one, this one. If you actually look at this, you can see that the global mean temperature actually has gradually declined. It took 9,500 years to get 1 degree cooler. Right now, we're where we were 8,700 years ago. It's really nothing to worry about. The global mean temperature is no different than it was 8,700 years ago. Everything was fine then, everything is fine now. The problem is, if we were to let this go up another couple of degrees, we will melt the polar ice cap. Now, you've probably seen a lot of literature about the fact that we've seen significant shrinkage of the polar ice cap. However, that shrinkage is the summer polar ice cap. When you shrink the summer polar ice cap, it drops more rain on Canada and Siberia. That's not going to cause an ice age. If you shrink the winter ice cap, that will generate an ice age. And I've written articles, you can see this at reasons.org. Every week I've put out an article called Today's New Reason to Believe. And in a couple of those articles I make the point, yes, the summer ice cap is shrinking and shrinking rapidly. But the winter ice cap, at least for now, is stable. And that's what we need to look at. If the winter ice cap begins to shrink, we're going to be dumping more snow on Canada and Siberia, and an ice age won't be far off. But we got time. And basically what I've done in my book is to say the problem with the climate change debate, we're ignoring two critical biblical principles. Principle number one, the Bible tells us human beings are fundamentally selfish. We look out for number one. And so when the governments of the world say, hey, we got a problem here. What we need you to do is shrink your standard of living by a factor of 2. If you do that, we can fix this global warming problem. We can restore climate stability. You know, I've tried that on my sons and my sons' friends, saying, you know, would you be okay if you were to live on half the income you got right now? And they basically say, we would rather to have an ice age come than to try to live on only half our income. People are fundamentally selfish. Moreover, we in the United States or Western Europe, we could make the sacrifices. What guarantee is there that people in China, in India, in Iran will make the same sacrifices? People will cheat. Nations will cheat. I guarantee if our government were to pass a law saying, hey, we all have to stop driving vehicles that burn fossil fuels, and you can't air condition your homes anymore, you can't heat your homes anymore. Maybe some people will go along with it, but I guarantee there will be people that will cheat. It will happen. Principle number 2, it tells us in the book of Genesis, God says to Adam and Eve, and to all of us human beings, I'm putting you in charge of planet Earth and all of its resources. I want you to manage the planet's resources for your benefit and the benefit of all their life. Now, what we're hearing from the Al Gores of the world is we have to make a choice between what's good for us and what's good for ecology, what's good for the rest of the life on planet Earth. We get a different message in the Bible. Basically, God is assuring us, I've given you all the resources you need so that you can manage this planet and its resources, not where you have to choose between your benefit and the benefit of life. It's going to be a win-win. There are solutions in which you'll do it for your benefit and the benefit of all other life. So I'd like to focus what short time I have here on just suggesting a few solutions that are win-win-win. They stabilize the climate, they are the best for enhancing the welfare of all the life on planet Earth, and they boost the world's economy, and they especially boost the world's economy for the poorest people of the world. Everybody wins. And where everybody wins, there's no need for the government to get involved. There's no need for laws. There's no need to say, hey, you know what, we're going to make electricity so expensive, you're going to put solar panels on your roof. And here's a couple of suggestions. Number 1, we can shrink the world's deserts. Human abuse, human sin, has caused the Sahara Desert to be 10 times bigger than it was in the days of the Roman Empire. If you read Roman Empire history, you'll recognize that what is now the Sahara Desert was the breadbasket for Europe. That's where Europe got all of its grain. We'll say, how did the Sahara Desert get as big as it is? People living on the south edge needed cooking fuel. So they would strip the land of shrubs, whatever they could find, and they would use that to cook their meals. And in the latter part of the 20th century, the Sahara Desert was marching south at a rate of 6 miles per year. It's now bigger than the continent of Australia. But we could replant it. And so one of the suggestions I make in my book, let's give the sub-Saharan peoples all the kerosene they want for free. They can use it to heat their homes, they can use it for cooking, on one condition, they work with us to replant the Sahara Desert. How quickly could we replant it? Within 1 generation, we can replant it. And now the Sahara Desert would be an income source for all the people living there. They could plant grain. That grain would suck up huge quantities of greenhouse gases, which would help cool the planet. And you could feed the hungry peoples of the world, and the people living there would have a source of income where today they have nothing. This is what the Sahara Desert looks like. You've probably also heard a lot of scaremongering about the Amazon jungle, how we're stripping the Amazon jungle, and they got a point. If we continue to deforest the Amazon jungle and transfer it into pasture land, we will basically turn the Amazon into a desert. Most of the rainfall in the Amazon comes from the trees there transpiring water to the atmosphere. And so if you cut down all the trees, you've got a problem. So, for example, over half of Earth's rainforest is in the Amazon, and in 1970, it covered 4,100,000 square kilometers. Today, only 3,300,000. So in just 50 years, we've shrunk it by 20%. Now, here's the problem. You cut down the jungle, make it pasture land, you raise beef cattle, you'll make money for 10 years. But at the end of those 10 years, your pasture land becomes a desert, and now you can't make any money. Now, what I propose in the book is, let's go into the Amazon and make it more productive in terms of generating income and more productive in pulling greenhouse gases of the atmosphere. And this applies here to North America. North America, we've got rainforests here too. But what do you notice about this photo of a rainforest? Lots of dead material, because we're not cutting down the big timber. We're just letting it sit there because we're trying to protect the forest. Well, when trees get big and old, they wind up dying, and when they die, they decay and release greenhouse gases to the atmosphere. And when trees get old, the degree to which they pull carbon dioxide out of the atmosphere shrinks by a factor of 4. And so we'd be much wiser to go into the forests of the world and selectively cut down some of the big trees. Not all of them. You need big, tall trees to sustain the ecosystem, but you don't need as many as we got. It would be far wiser to selectively cut down these big old trees, use them for furniture and housing, which means we store the carbon in a way that doesn't get released to the atmosphere, and you replant the trees you cut down with young trees that are going to grow 2 to 4 times faster than the old trees. This is where you make the most money in terms of lumbering, because you make more money from the big trees. And by replanting them, you basically ensure you're going to maximize the income from the lumbering, and you pull out the most greenhouse gases. You also enhance the ecosystem. And so this needs to be done in our national parks. I've been to some of our national parks. A third of the trees are dying. Why? Because we've got too many trees. They can't compete for the water supply there. It would be far wiser to let the lumbering companies come in the wintertime when there's no tourists around. They can selectively pull out the big old trees. That would make for a much healthier forest. And guess what? Tourists like healthy forests. They like to see green trees. They hate to see brown trees. And moreover, the wildlife will come back. Tourists like to see wildlife. And so they could actually charge more admission fees to go into the national parks. And so instead of this, we could actually have healthy forests that generate lots of income, great for the tourist industry, great for the wildlife, and it generates income. Now, one of the most radical things I have in weathering climate change is we can get an immediate 50% drop in greenhouse gases with one simple thing. Stop burning coal, burn natural gas. When you burn natural gas, it emits half the greenhouse gases that you get from coal. You burn coal, it produces carbon dioxide. You burn methane, natural gas, you get water and you get carbon dioxide. But the water is stable. It is a greenhouse gas, but too much of it in the atmosphere falls as rain. Well, there's a lot of places in the world that are short of rain today. Burning natural gas will increase the rainfall. You immediately drop the greenhouse gases down by 50%. And what they discovered in Canada, what's warming up Canada so fast is not carbon dioxide. What's warming up Canada is the deposition of black carbon soot from the burning of coal in India and China. The weather patterns take all that black carbon soot from India and China and they dump it on northern Canada. And that black carbon soot falls on the snow and ice and causes it to melt much more rapidly. If you stop burning coal, that takes care of all the black carbon soot. It also takes care of all the respiratory diseases that are running out of control in India and China. So their population would be much more productive, it would be healthier. Natural gas is cheaper to burn than coal. It's easier to transport. Literally, everybody wins. You get an immediate, there's nothing on the horizon that gives you such a rapid drop in greenhouse gases as simply trading one fossil fuel for another fossil fuel. And what I really am pushing in weathering climate change, let's use natural gas to buy us enough time to scale up thorium nuclear power generation. Now, there's a huge anti-nuclear lobby in the countries around the world, and there should be. With uranium nuclear reactors, you've got toxic waste that lasts for 50,000 years. It takes 50,000 years for it to become safe. And as we're well aware, with nuclear power generation, you run the risk of a meltdown that could wind up throwing radioactive waste out thousands of square miles, like what happened in Ukraine a few decades ago. And you run the risk that people could use those nuclear reactors to make nuclear weapons. And moreover, nuclear power generation is not cheap. Thorium can come to the rescue. These are thorium nuclear reactors. They were built in the early 1960s in the eastern United States. The reason why they didn't scale it up, they said with thorium nuclear power reactors, it's impossible to make weapons. And we wanted weapons, so we said, we've got to forget about thorium. We've got to go with uranium, because there we can get weapons. But today, that's an advantage. The fact is, we could give thorium nuclear reactors to North Korea and never worry that they're going to turn into nuclear weapons. It's impossible. Well, it's not actually impossible. It is possible to get a nuclear weapon from a thorium nuclear reactor, but in the process, everybody that works on it dies. So there's not a lot of motivation to make a weapon out of a thorium nuclear reactor. Anybody who tries it will be killed. Okay, some advantages of thorium. It's 3 times as abundant in the crust of the Earth as uranium. And 1 ton of thorium gives you the energy equivalent of 200 tons of uranium or 3.5 million tons of coal. So look at all the energy you get. The United States has enough thorium to produce 100% of the U.S.'s total power needs for the next 1,000 years, and the U.S. does not have the biggest store of thorium. India's got way more thorium than we have, Canada, lots of other nations. You get 1,000 times less radioactive waste. The waste is safe to touch within 50 to 200 years. So you don't have 50,000 years, you're looking at a few decades before it's safe to touch. People that mine the thorium don't have to wear special suits. People working in the reactors don't have to wear special suits. The radioactive risk really isn't there. It's safer and more efficient to mine, much cheaper to mine. You can strip mine it. You can't have a meltdown. It's impossible to have a meltdown with a thorium nuclear reactor. How long would it take for us to scale up where 100% of our energy needs could be met from thorium nuclear reactors? 10 years. But methane, natural gas, can buy us a 10-year window. And again, it'll actually produce power cheaper than hydroelectric. Hydroelectric now is the cheapest electricity source on the planet. But there's only a few places in the world where you've got enough of it to provide their needs. I've got a friend that lives in Canada who has one of these electric cars, 5-passenger electric cars. He drives it 400 or 500 miles every week. And I say, well, how much do you have to pay to keep the car going? He says, I can keep it running for 50 cents a month. That's because he gets all of his energy from hydroelectric. With thorium, we can beat hydroelectric costs by a factor of 2, produce electricity for half the price of hydroelectric power, and there's enough that we could supply all the energy needs of the world. That's just a few of the examples. I actually have a total of 40 win-win solutions to climate change, basically saying we don't need laws, we don't need penalties, we don't need taxes. All we need to do is share with people, would you like to have a 20% per annum return on your investment? And what I've heard from economists, if you can show people a 7% return on their investment, they'll do it next week. If you show them 20%, they're on it right away. So this isn't politics. We can take the politics completely out of it. This is something I've shared with my friends in Washington. This is something every Democrat could love and every Republican can love, and maybe we can get rid of this polarization that happens at the political level. Okay, I'll take questions. again, on any subject that you care to raise. This is my last time with you in the evening. Yes? Where does the water come from? Okay, I'm not quite hearing you, so can you tell me what he's saying? Oh, the comets. You're talking about comets. Okay. Water is the third most abundant molecule in the universe. I mean, I got NASA saying, follow the water, you'll find life, and I'm saying, wait a minute, the universe is soaking wet. The most abundant molecule is hydrogen 2. The next one is hydrogen 3. After that, it's water. Water's everywhere. So we shouldn't be surprised that in planetary systems, once you get far enough away from the star, you've got lots of frozen water. And that's where the comets come from. They come from that region beyond Jupiter. And so as they are disturbed by the gravity of Jupiter and Saturn, several of them. By the way, we get about 10,000 comets impacting our atmosphere every day. Most of them are mini comets. And you know, our planet actually loses a tiny amount of water to interplanetary space. And that's optimal. If we were to increase the gravity so the water wouldn't lose, so our planet wouldn't lose any water at all, we'd be retaining ammonia and methane at such levels it would cause the extermination of all life. So it's crucial that we lose a little bit of water so that we can have the diversity of life we see on planet Earth. But the water we lose is compensated by the water we gain from comets. It's all in a beautiful balance that's kept the water level on planet Earth just right. And by the way, now that we're looking at these planets outside of the solar system, we're finding that what's really special about planet Earth is how water poor it is. We're now finding planets of the same size as the Earth and the same distance from their star. They're coming with a water content 500 to 1,000 times greater than the Earth. With too much water, you actually get ice at the bottom of the oceans. We don't get ice at the bottom of the oceans because the oceans aren't thick enough. But you add 100 times more water, you will get ice at the bottom, which means you get a permanent barrier between the water and the rock and no possibility for life. Our planet is 0.02% water. What we're seeing in the Earth-like planets is 5 to 10% water. So too much water is a problem, too little water is a problem. Our planet has exactly the right amount of water, kept in just the right balance, because we have these perfectly fine-tuned comet belts. Now, other stars have comet belts, but the stars that have comet belts, their comet belts are 1,000 times bigger than ours, which means you get too much water delivery. And you don't want to have a comet crashing into your house every day anyway. Okay, who's next? Yes.
So you were talking about thorium. What's the main reason that you hear that they don't use it? Or is there one?
Well, most of the people, when they talk about nuclear power generation, they're thinking uranium. They're not thinking thorium. All the disadvantages of uranium are taken care of with thorium. So it's an education thing. People don't realize there's an alternative to uranium nuclear power reaction. So that's one thing. The other thing is scaling it up. Those reactors I showed you were small reactors. If you really want to produce all the energy needs for America, you need to build thousands of big thorium nuclear reactors. Now, there's always a question, can we scale up these thorium nuclear reactors in enough time with enough safety, and can we get past all the regulatory groups? And so the problem is that our regulatory governmental agencies treat thorium the same way they do uranium. So again, we got an education problem. They need to realize thorium is in a different category than uranium. And once that happens, I think we can scale this thing up quite quickly. And what we learned from other scale-ups is always what we notice when you scale up, you wind up with an economically more productive result. It's always more expensive when you've got a small reactor as opposed to a big reactor. So I personally don't see any engineering difficulties with scaling it up to a point where it produce 100% of our energy needs. In the back? Yeah, I mentioned that in my book on weathering climate change, that cows are a huge contributor to greenhouse gases. They belch out huge amounts of methane and carbon dioxide to the atmosphere. And also, to support them, we have to cut down a lot of forests and transfer to pasture land. When you do that, you're storing a whole lot less carbon on your agricultural lands. And so I raised up the point, what if we replace our consumption of beef with consumption of ostriches? Ostriches can produce meat for half the price of turkey. Turkey meat now is the cheapest meat in the market, but ostriches can beat that by a factor of 2 if you scale up. And ostrich meat, unlike beef, by the way, it's just as iron rich as beef. It's a red meat. It has the flavor of beef, but it doesn't have the saturated fats. It doesn't have the cholesterol. It's the optimal meat to give to people that are diabetic. It's the healthiest meat that you can get. And the other thing about ostriches, you get eggs. 1 ostrich egg is equivalent to 23 chicken eggs. So you get the eggs, and you got the feathers, and you can get, for example, the amount of pasture land you need to get beef, to get the same amount of meat, you can cut that down to 2% with ostriches. Now, there is one negative, and I know a lady that breeds ostriches, and she keeps trying to talk to these ranchers and telling them you can't treat ostriches the same way you do beef cattle. I mean, the thing about beef cattle is you throw them out into a pasture, you can ignore them. They take care of themselves. They don't need any attention. Ostriches are highly social birds, and so the way you make money on ostriches, make pets out of your ostriches. They love humans, and in terms of how they operate, they mate for life, and so a male ostrich and a female ostrich will mate for life. That bond is retained, and ostriches love one another, so family groups form, but they need human contact. And so you need to be involved with your ostriches. So lots of ostrich farms have failed because the ranchers have tried to treat the ostriches like they do the beef cattle. Run them, let them roost in the field. They don't need a big field. They're fine with a small area, but they're highly social birds, whereas cows, sociability isn't a big factor. But yeah, it's another example of when you get cheap meat, it's healthy meat, and you release just a tiny fraction of the greenhouse gases that you do with beef. And you get eggs. Yes?
So when you were talking about the glacier on top of North America, you're saying how it kind of pushes North America down and then when it melts, it rises back up. Were you saying it pushes towards the core or down to the...
Yeah, what I'm saying is that when you've got North America covered with thousands of feet of ice, that weight pushes the North American continent into the upper mantle of the Earth. And when the ice melts, you get a rebound. And with that rebound, you get the ignition of volcanoes, because suddenly all that lava in the upper part of the mantle gets released through fissures, and you produce volcanoes around the world. Volcanoes produce very nutrient-rich gas and dust and ashes. And so, I mean, we see that. Whenever there's a huge volcanic reaction on a small island, everybody leaves, but they return quickly because they know they're going to get a really rich harvest of food because of how nutrient-rich that volcanic soil is. But this is a worldwide event. Basically, all the agricultural plains had huge depositions of this volcanic ash.
But with the North American continent being pushed down, did that cause the Caribbean tectonic plate to rise up more islands or mountain range in South America or in Florida?
Well, you see parts of the world being pushed down, and you're right, other parts will rise up. But the fact that the ice melts as fast as it does, And we're talking thousands of feet thickness of ice over millions of square miles melting in just 1,000 years. This is what causes a rapid rebound of several continents, not just North America. Asia goes up, Europe goes up, other parts go down, but the net result is you get volcanic eruptions all over the world. Okay, there's another question in this, yes, right here.
So I know you touched on the nuclear energy, but do you know any other reason why business people or governments haven't hopped on any of these other win-win scenarios you talked about?
Well, they are beginning to recognize there's a better way to lumber. Instead of clear cutting, which is a typical way that lumbering works, where they just clear cut, say, a square mile and leave the rest alone, then they replant it. They're beginning to recognize, rather than clear cutting, let's go through the forest and select out the trees that are the biggest problem for global warming, but also the trees where we make the most money, then replant it. So you actually keep the whole forest intact. You don't clear cut. You selectively cut. The forest remains the fastest growing and the healthiest in spite of the lumbering that you're doing every year. So that's the principle, and people are catching on to that. And so there's now a movement, hey, we need to invite the lumbering companies to come into our national forests and national parks. And we do it at a time when the tourists aren't visiting. Yes?
So, I came on Sunday to the service, and I missed Tuesday, Wednesday, Thursday, and I got the book, Design to Record. So what I'm hearing, correct me if I'm wrong, is that reasons to believe, science is you're telling us science proves there's reasons to believe, and God, 14 billion years ago, did, and correct me on the dates, all of a sudden started this whole transaction that got us to this point of this period where life is able to live on the planet.
Yeah, you got it all. That's exactly what we're all about. That's why we produce the 30-plus books we've done, and we're committed to produce another 30, is basically to communicate that message.
And you as a scientist, I guess, it makes me kind of go, holy moly, this God is huge.
That's exactly how I want you to respond. I think the peoples of the world have too small of a view of God. God's way bigger than what we can imagine. And so that's kind of what I'm trying to do with the students at Anchor House, is realize God's much more intimately involved in our lives, in our universe, in our planet than we've ever thought of before. And He's a God that is providing for us at a level. I mean, what I'm trying to do here with this talk is say, this climate stability we got is no accident. This is a gift from our Creator God. It's a gift at this unique time so that billions of people can hear and respond to the gospel. What you see in the book Designed to the Core is that before God created anything, He developed His plans for redeeming billions of people. Everything He creates is for the purpose of bringing billions of human beings into a redemptive relationship with Himself. I think as I shared this on Sunday morning, what I'm doing with my peers who are not yet Christians is simply challenging them. Look, I know you're not a believer, but if you will do your scientific research from a biblical redemptive perspective, it'll make you more successful at making scientific discoveries. I'm convinced of that because I'm convinced everything God creates has a redemptive purpose. Therefore, if you look at the science from a redemptive perspective, you will make more scientific discoveries. And of course, I'm hoping that my scientists who are not yet Christians will realize this is the handiwork of God. I need to really consider the Christian faith. Yes?
Earlier in your talk, you mentioned something to the fact that you could show that we're living in the end times. I may have missed it.
Okay. Well, basically what I'm saying in weathering climate change is that we can restabilize the climate. We can continue this climate stability that we've been enjoying for the past 1,000 years or past 9,500 years. But we have the tilt of Earth's rotation axis now at 23.5 degrees. It's going down to 22.1. It will continue to cool the planet. Likewise, the changing shape of Earth's rotation or revolution around the sun is cooling the planet. It's only a matter of time before the next ice age hits. It's going to happen. What I say in the book is, if we do everything right, we can probably put it off for as much as 1,500 years. Now, if you're premillennial in your eschatology, you're going to need 1,000 years for Jesus to reign on earth. So you at least want to work things out so we get 1,000 years. But given that the maximum is about 1,500, that means we should be looking at the return of Christ, again from a premillennial perspective, sometime within the next 500 years. Now, what I put in the book, though, is that human beings, like this I got from Ralph Winter, who is the founder of the U.S. Center for World Mission, and he wrote about this saying, evangelical Christians today have the finances, they have the people, they have the technology to fulfill the Great Commission, to take the good news of salvation to all the people groups of the world. They can do it within 5 years. All they lack is a motivation. Well, what I put in my book is I think a more conservative estimate is 10 years. But here's the problem. Ralph Winter also said we can do it within 5 to 10 years if we can get all the evangelicals investing 1% of their income into fulfilling the Great Commission. But here's the problem. If you survey evangelicals around the world, the average is 0.1%. Now, what you do find is lots of evangelicals that give it a rate of 5 to 8%. They support their churches, but they also give in addition to that to fulfill the Great Commission. As I shared with Ralph Winter, trying to get those people to increase their giving by a factor of 10 won't work. I'm not in a position where I can give 80% of my income to fulfilling the Great Commission. What we need to do is motivate the millions of evangelicals who give nothing. So if we can get them up to 0.5% or 1%, we can get it done within a decade. All we lack is a motivation. That's why I like to share with people about the new creation. Say, Christianity is a two-creation model. He creates his universe to be a tool to eradicate all evil and suffering. But once that happens, he will speak the universe out of existence and bring us into the new creation. And the new creation is great. Read Revelation 21 and 22. Why wouldn't you want to go there? Why wouldn't you want to go there tomorrow? So we should be motivated of all people to speed up the fulfillment of the Great Commission. But I was sharing with the Anchor House students today that the last survey done by Barna shows that only 5% of evangelical Christians who attend church every week have shared their faith with an adult non-Christian in the past year. If we're going to fulfill the Great Commission in less than 500 years, we got to get that percentage up above 5%. You say, what's the biblical standard? 1 Peter says it should be 100%. We're all to be involved. Always be ready to give good reasons for the hope that you have in Jesus Christ with gentleness and respect. We should all be ready to share our faith. And that's my passion. I told the students, yes, I'm an astrophysicist, I'm a pastor, I'm a seminary professor, but my primary occupation is evangelist. And that should be the primary occupation of every evangelical Christian. We can get it done in a decade. We don't have to wait 500 years. But I'm saying based on the physics and the chemistry and the biology, that's the limit. So, but if you're not premillennial, then you can extend it a little bit more. I'm not going to get into those dialogues. Okay. Any more questions? In the back, yes. Nuclear fusion. Well, I took a lot of plasma physics classes when I was a physics student, both at the undergraduate level and the graduate level. And I remember my professor saying back in the 1960s, we'll have nuclear fusion reactors producing all the electricity we want by the end of the 20th century. Well, here we are in 2022, and we're about the same place we were back in 1960. We're not making a lot of progress. Now, there's a caveat to that. We are making progress, but the pathway to generating electricity from nuclear fusion, we now realize, is going to be expensive. It's not impossible, but it will be expensive. And the sun does it, but the sun uses gravity to contain the plasma. We're trying to contain the plasma with magnetic fields or with laser beams. Extraordinarily difficult. Plasma is highly unstable. I'm convinced eventually we will be able to control fusion with electromagnetic radiation, but it won't be cheap. Thorium nuclear reactors are going to be orders of magnitude cheaper, and we know how to build them. There's no engineering difficulties, whereas there's enormous engineering difficulties with nuclear fusion. Yeah, it would produce abundant energy, but we're not technologically there yet. Yes?
Two questions. One of the questions would just be, because when I have traveled in different parts of the world,
What kind of travel?
I've just done travel in
Okay.
the East, and I've flown over the Sahara. And at certain times of the year, the dust of the Sahara is everywhere, and I wondered if that played a factor. That's detrimental. It's not like volcanic ash and stuff.
Yeah. Well, you are right that when you go to the Gobi Desert, the Sahara Desert, you get these huge dust storms. The dust is not nutrient rich, so it's not like what happens when you get the dust flowing off the high plateaus and being dumped on the low agricultural plains. And the dust that comes off of the Sahara Desert is not good to breathe. And so a lot of respiratory diseases on the east coast of the United States, a lot of that is being generated by Sahara dust. So, and a lot of that Sahara dust, because thanks to the westerlies, gets blown into North China and in Japan. So that's another reason why it'd be a good idea for us to shrink the Sahara Desert. We could take care of the dust problem.
My other question had to do with how you factor in God's judgment.
How do you factor in?
God's judgments, where He brings famines, and
Right. Okay. I think you're referring to the book of Revelation where it says in the days before the return of Jesus Christ to planet Earth, there will be certain catastrophes that will fall upon humans. One of them says that the sun will scorch people with unbearable heat. And so I've run into people, in fact, I'm going to be doing a debate on climate change in November. And I know one of the debaters there is going to be making the point, hey, you know, I don't think we're going to solve this climate change problem. The planet will get warmer, and when it gets warmer, we're going to have this huge problem, especially in the big cities, because cities are heat islands. So, you know, I lived in Toronto with 10 million people, and in the summertime, the temperature in the city core was 10 degrees warmer than it was in the suburbs. You got that problem all over the world. So even a little bit of global warming could lead to a lot of deaths, especially in the big equatorial cities. Africa is already experiencing that. And so that could be a fulfillment of Revelation chapter 8. So I'm not saying we got a guaranteed pathway. You still got to deal with, you know, humanity. You know, what I'm talking about in weathering climate change, it'd be great if everybody knew about these solutions. But I mean, if you read online about global warming and climate change, you won't hear the kinds of things that I'm mentioning in my book. It's just not there. Or what you see there is barely a hint. I wrote the book to try to get the word out. There are solutions. We don't have to take the route of punishing taxes and crippling the world economy in order to solve this. It won't work anyway. Whenever you do that, people dig in their heels. That's just going to slow things down. And one thing I mentioned in the book, I believe this global warming is a sufficient crisis. We need to act upon it now, not 10 years from now. If you want to act upon it now, you have to give people an economic incentive. You're not going to incentivize them with punishing taxes. You have to incentivize them by saying, this is going to increase your standard of living. It's not going to decrease it. And they say, I'm all in. This means I'm going to have more money in my bank account, I'm in. Gentleman in the back.
I appreciate you, talking about a few of the pieces about, man-made global warming and recognizing that and giving that, voice, because it's a tough world
witnessing, right? And if we come across as, hey, we've got this book, don't worry about anything, we've got a new ice age coming, we're probably going to alienate more people than, you know, to be able to help them, you know, witness to them. It's just, it's tough, right? So I appreciate you saying that we've had a long time of stability, we're not there anymore, we're starting to get out of control. If we don't get that settled, then yeah, we're going to have some big time problems, and we don't have a lot of time to deal with it. And I understand the, you know, the global piece and everything with different countries, but, you know, per capita, right, it's us, right? We're just,
Yeah, and the thing we got to deal with is you don't want to cause panic. And that's, to me, is what I'm trying to deal with, is in terms of this global warming debate, we got politicians and scientists trying to generate panic to a sufficient degree that people be motivated to make the economic sacrifices. I'm saying, hey, a far better way and a more expeditious way is to motivate them economically. And so, yeah, we do have a crisis, but hey, there's a way to go forward where we're actually going to get people moving in the right direction, because everybody's going to be better off. We increase the economic well-being, and we increase the health of people. A lot of what I put in the book are the health benefits of these solutions. We're talking about ostrich meat. There's a health benefit there.
well, fossil fuel pollution kills like 8 million people a year.
Yeah. Simply getting rid of coal and going with natural gas has a huge health benefit for all the peoples of the world. The problem is we got people who say, we want to get rid of all fossil fuels and get rid of it immediately. Well, number one, we don't have an alternative. There's not enough wind power, there's not enough solar power to take it over. And hey, if you're trying to generate it all with solar power, look, I walked around here on Kauai. What I saw 30 years ago was a beautiful farm. Now it's covered with solar panels.
We're at 70%, and we're heading to 90 in a few
Yeah.
years. So we're an example of that can be done quickly.
It can be done quickly. However, I'm not a big fan of solar power generation because you've got to recycle those solar panels. I live in California. They gave us this big tax incentive to put solar panels on our roofs. We all did it because the price of electricity was jacked up so high. Basically, the state forced us to do it. 20 years from now, we got millions of solar panels that have to be recycled, and there's no recycling plan that's set up to deal with it. Now, I am excited because there's a new technology where you get solar panels that produce twice as much energy per square foot as we get right now. We don't have it yet, but it's coming. And the wonderful thing is that stuff can be recycled. The panels we got now, we got a huge recycling problem. And the problem I've got with wind, it kills birds. And you know, I live in a place where they have really strong winds, but it varies. So there's a huge wind farm out by Palm Springs. But if you drive out there, only a quarter of the windmills are turning. Because to get efficient electrical generation, they have to tune it to a particular wind velocity. Well, the winds out there are always blowing, but they're not always blowing at the same miles per hour. So they have all these different windmills tuned at different velocities, but the bottom line is only a quarter of them are working at any one time at best. Sometimes only 10% of them are working, and they kill birds. And what a lot of people don't realize, windmills have a huge carbon footprint. It takes a lot of carbon in order to erect and maintain those windmills. And so there is a better way to go. Yes?
Do you think the rapture will happen before humanity experiences catastrophic failure from...
Well, I run into that a lot. I am premillennial in my theology, so I'm with you there. But where I'm a little bit concerned is people are saying, let's not worry about any of this. The rapture is going to happen soon. It doesn't matter how much we mess up the planet. We're going to be out of here in short order. Well, God told us, occupy until I come. He put us in charge of the planet. We're managers of this planet. I would rather get an A grade from the Creator for how well we manage the planet than an F minus. And so rapture theology, it should never be an excuse to mismanage the planet or to abuse the other life forms that share this planet with us. Okay.
When you talk about your solutions, let's
Well, the scientists are beginning to wake up to the advantages of thorium. And certain nations that have a lot of thorium on their land, they're beginning to wake. So India, which has the world's largest store of thorium, they're starting to look at thorium nuclear power reactors. Israel is starting to look at it. Canada, which has a large deposit, is looking at it. And the US is now on board. But in all these nations, it's at a small scale level yet. They're not really gearing up, mainly because they realize there's a huge anti-nuclear lobby they got to get past, which is why I think we have an education problem. We need to communicate to the taxpayers, thorium is not like uranium. You can't make nuclear bombs. There's no possibility of a meltdown. All the things that people worry about with nuclear power reactors, basically thorium takes that away. And so we need to get people thinking thorium, not uranium. It will take time, but I think the politicians are going to have to get involved. Talk radio show hosts are going to have to get involved. Popularizers. It's not enough for a few physicists to talk about this. We need to get the information out to a broader community.
And that's where I was kind of going to this. How a lot of times business can drive a lot of what gets done through. I just didn't know if there was any.
Yeah, I think if we can get some wealthy entrepreneurs aware of this stuff, they'll say, hey, well, I can make a lot of money on this. And then they'll get into it. So far, it's all at a scientific level. It's not yet at a business level. That's where we need to go. In the very back.
I was just wondering if maybe all the solar panels that farms we have, if that also can create some heat, that might in turn.
Yeah, I'm having a hard time hearing your last part. There's fans here that make it hard for me to hear.
Can solar panels cause heat?
Can solar panels cause heat? Yeah. Well, the nice thing about solar panels is that they're making electricity, but they tend to have a high reflective surface, so they reflect away a lot of solar heat, and they actually cool the ground underneath it. So that's considered a plus with solar power generation. It actually helps cool the planet in two different ways. Now, it does mean you're taking agricultural land out of production, which is why people are saying, well, maybe we should only be doing this in the deserts where we can't grow anything anyway. That's the strategy in California. Let's carpet the Mojave Desert with solar panels and leave the San Joaquin Valley alone, where we grow all our food. Okay, well, thank you. I will be giving a message on the North Shore on Sunday, and I'll be with the students tomorrow. But it's been a pleasure to be with you. I always appreciate being at Kauai Christian Fellowship. We need more churches like Kauai Christian Fellowship. So thank you for welcoming me back.